This is AP Calculus AB. We're looking at the release question from the 2008 AP final. It's question number 5. Consider the differential equation y minus 1 over x squared where x can't be 0. Now when it tells you x can't be 0, that means we don't have to put anything here on the y-axis. That's important. On the axes provided, sketch a slope field for the given differential at the 9 points indicated. All right, so let's check this out. Let's first figure out when would the slope be 0. It's how I always start these out. The slope's going to be 0. Let me make a table here. Slope's going to be 0 whenever y is 1. So x could be anything, and if y is 1, with the exception of where it's undefined, which it's undefined once again here. So in that case, we're going to have 1 divided by a number, or 0 divided by a number, so the slope's going to be 0. That's whenever y is 1, and that is happening here, here, and here. You do that correctly, you're going to get yourself 1 point on the AP exam. Well, what about when y is let's do this. Let's focus on x right now. Since this x is being squared, whether it's positive or negative, you're going to get the same answer. So if we do plus or minus 1, and let's say the y value is negative 1, that would be negative 2 over 1, which is negative 2. So when x is negative 1, we don't have to do, I'm sorry, there is no y value of negative 1. Let's do 0. So when y is 0, that's going to be negative 1 over 1, which is negative 1. So at negative 1, 0, the slope's negative 1. And at positive 1, 0, the slope's negative 1. Let's do x being plus or minus 1 and y being 2. It's going to be 2 minus 1 over 1, which is a half. Just confirm. Nope, I'm sorry. That's not right. Something didn't feel right. I didn't know what it was. 2 minus 1 is 1. 1 is 1. So the slope is 1 here and here. And then we're left with 2 more ordered pairs. We got the ordered pair 2, 0. So that's going to be 0 minus 1 over 2 squared. That's going to be negative 1/4. So that's pretty shallow, but negative. And then the last one, just running out of space here, the ordered pair 2, 2. That's going to be 2 minus 1 over 2 squared. That's going to be a positive 1/4. Pretty shallow, positive slope. You would get an additional point if you made those slopes positive. Let me highlight if these red slopes positive and you made these blue slopes negative. That's how the rubric reads. 2 points total. B, find a particular solution to this function that's differential with the initial condition to 0. So we have this function as differential dy over dx equals y minus 1 over x squared need to separate our variables. Going to, let's see here. Going to divide both sides by y minus 1. and multiply both sides by dx. And we're going to integrate these, and there's still some things I want to change here to do this integration. On the left, I'm going to set u equal to y minus 1. du over dy is going to be 1. du is going to be dy. So we're going to be integrating 1 over u to u. On the right, I think it might be wise to change this to integrating x to the negative 2. On the left, if you integrate this, you're going to get natural log of the absolute value of u. On the right, add 1 to the exponent, multiplied by the reciprocal, throw in your arbitrary constant. U doesn't really exist in this problem, so it's natural log of the absolute value of y minus 1 equals negative 1 over x plus your arbitrary constant. Then we got this ordered pair 2, 0. So we got f of 2 equals 0. So if we put 0 in for y and 2 in for x, we're going to get natural log of the absolute value of negative 1 is negative 1/2 plus c. That's natural log of 1. Natural log of 1, just to refresh your memory, that's 0. The reason it's 0 is because we're saying log base e of 1 equals 0, which is asking the question, well, I'm saying it's 0. Let's say that we don't know what it is. It's saying e to what exponent is 1, which of course is 0. So that means c is 1/2. So we got natural log of the absolute value of y minus 1 equals negative 1 over x plus 1/2. We want to solve this for y. I'm going to get the absolute value by itself. This is currently in log form. We're going to change it to exponential form, which is going to be e to the negative 1 over x plus 1/2 equals the absolute value of the difference of y and 1. Now for some problems, we took this and we changed it into e, don't write this down, e to the negative 1 over x times e to the 1/2. We could do that for this. It's just not that helpful. Why was it helpful before? Because one of these terms in the exponent had a natural log in it. This doesn't, so it's not helpful. I'm going to separate this into two separate possibilities. We have the negative version of this, and we have the positive version of this. If you solve the negative version, you get this bad boy. Solve the positive version, you get this bad boy. Now the question is, which equation contains the ordered pair that we were given of 2, 0? Well, let's just reason this out. If we put a 2 in for this exponent is going to be negative 1/2 plus 1/2, which is 0. I'd make this e to the 0, which is 1. 1 minus 1 is 0. We would get 0 equals, we would get 0 equals 0. So that works for that one. So I'm assuming that's the correct one. We'll check the other one just to make sure. So I'm thinking it's f of x equals 1 minus e to the negative 1 over x plus 1/2. So whichever equation can contain this ordered pair. If we put a 2 in for this and a 0 in here for y, we're going to get 0 for an exponent. E to the 0 is 1. 1 plus 1 is 2. We would get 2 equals 0. 2 does not equal 0. So this is the correct answer. How do points go for this? I believe this one was a point for separating your variables, a point for integrating each side correctly, a point for using the initial condition, a point for finding C, 1, 2, 3, 4, 5, 6, and then a point for getting the correct equation. Part C, a limit. I haven't done one of these in a while. For the particular solution described in Part B, find this limit. Well, if you didn't get this particular solution right, you're going to get this wrong. So we want to find the limit as x approaches infinity of f of x, which is 1 minus e to the negative 1 over x plus 1/2. If you recall, this is just a quick review. If you have 1 over x, where x is approaching infinity, this is always 0. Because as this bottom number gets bigger and bigger and bigger, this fraction is becoming smaller and smaller and smaller, closer and closer to 0. So with that in mind, if we evaluate this limit, 1 is going to approach 1. And this fraction here, negative 1 over x, as x approaches infinity, that's going to approach 0. And then 0 plus 1/2 is 1/2. So this is 1 minus e to the 1/2. You would get 1 point for evaluating that limit correctly. All right, that concludes the 2008 number 5 question.